So we have been learning about trig functions of just acute angles so far. The sine, cosine, and tangent ratios that we've had so far were only for acute angles. Acute means between 0 and 90. Now there's something called the unit circle out there, and this is going to be a brief introduction to it. We can technically calculate those functions for any angle, literally any angle. So remember, rotations of a circle don't just stop at one rotation, they go on forever and ever. So I could theoretically ask you to calculate the tangent of 12,358 degrees. It wouldn't be a lot of fun, but we could do it. So let's start looking on your notes. You have something that says let theta be any angle in standard position, and then P of xy is the point that the leg terminates. Okay, so we know that x is the x coordinate, y is the y coordinate. We have to find something called r. And if you look at this particular point that they graphed, x, y, if you filled in those coordinates, it kind of forms a right triangle. It exactly forms a right triangle. So the r value is what trig calls the radius. We're going to find that just by doing some quick Pythagorean theorem. So what I'm gonna give you now in your notes are new formulas for sine, cosine, tangent, cosecant, secant, and cotangent. However, they're actually the same formulas that you guys have already seen. For instance, sine is y over r. What was the formula that you guys have for sine? Opposite over hypotenuse. Now think about that. If theta is the angle by the origin, isn't the opposite of that y and the hypotenuse is r? So it's the exact same formula, they're just calling the legs of the triangle something else. Okay, so let's see this in action. So we have the point 512. If you would like a little picture of this, you could draw yourself a coordinate plane and think about where the point 512 would be. He'd be up here somewhere. And it doesn't have to be to scale, but it should be in the right quadrant. So if you think about this, 512, I'm not going to be able to draw real well here, but it does make a right triangle. The horizontal component to this right triangle is the x-coordinate, which was 5. The y-coordinate, or the vertical component, is 12. And then I need you guys to find the value of the hypotenuse, which we are calling the r. And remember from the last slide, the radius is just Pythagorean theorem. So find the hypotenuse. This one comes out nice. Anyone calculate that for me? 13. So you can either still think of sine, cosine, tangent the old way with your old formulas, or you can start to use our new formulas. So first they ask you for sine. Sine is y over r. So for this triangle, the y is 12, and the r you just found is 13. Cosine's formula, the new formula, is x over r. So the x is 5, and the r is still 13. And tangent is y over x, which is 12 over 5. The reason we start to think about sine, cosine, and tangent with these new formulas is because you don't have to have a picture in order to get the formulas. Because if you know the x, the y, and the r value, you can just quick plug and chug the numbers in. Cosecant's going to be the reciprocal of sine, so once you have sine, cosecant's easy, 13 over 12. Secant's the reciprocal of, whoops, not what I wanted to write, cosine, 13 over 5. And cotangent is the reciprocal of tangent, so 5 over 12. So again, you can draw this if you want, but I would like someone to just quickly calculate for me. If my x and y are 3 and 4, can someone calculate my r for me? It's a 5. It's a 3, 4, 5. So without even drawing a picture, I know my x, I know my y, I know my r. I think I can just plug into the formulas. Remember, sine was y over r. So for us, that would be 4 over 5. Cosine is x over r, so that would be 3 over 5. And tangent is y over x, so that would be 4 over 3. Could you still draw it out, make a triangle, do SOHCAHTOA the old way? Absolutely. But I think you're going to find that this is a lot quicker. Cosecant's going to be sine's reciprocal, so 5 over 4. Secant is cosine's reciprocal, 5 over 3 and 3 over 4. Okay, issues? Okay. You need me to go back? Number 3, we have an x, we have a y, and I think we could calculate r. So your r value is 8 squared plus, remember, negative 15 squared is going to be a positive value. Can someone calculate that on their calculator, please? Is it 17, or does this one not come out nice? 17. 17, okay. So our r value is 17. So again, you can just straight up use your new formulas. Sine is y over r. So the y, be careful, is a negative 15 over 17. Cosine is x over r, so 8 over 17. And tangent is y over x, negative 15 over 8. Once you have those three, the next three are really easy because they're just the reciprocals. Now, it doesn't matter where the negative goes. It could go to the numerator, off to the side, or in the denominator. So wherever you want it, just put the negative down. Just don't put two negatives. That would be positive. Secant would be 17 over 8, and tangent is negative 8 over 15. Same rule with the negative. It just has to be somewhere in the fraction. By the way, what quadrant would 8, negative 15 be located in? That'd be positive 8, negative 15. Yeah, down here. Anyone who's been in ACT prep recently? Anyone remember what that stood for? There's a mnemonic device. We're about to learn this, so if you don't remember, it's okay. All right. It's just things to come. Just hang on to it. All right, number 4. We have an x, we have a y, and then I think you could calculate your r really quickly. So negative 8 squared plus 12 squared. I don't think this one's pretty. Okay, before you square rooted it, can someone tell me what that number is? What's oh geez, I should be able to do this. 144 plus 64. Well, I know it's not that because it's got to be bigger than 12. You have your parentheses maybe. What was it? 208. 208. Okay, so this is the square root of 208, but I have a feeling 208 breaks down. Oh geez, could someone take 208 and divide it by 16? Tell me if that goes in evenly. 13? Cool. Okay, so 208, I'm going to write it down here, is really the square root of 16 times the square root of 13. So what really is the square root of 208? 4 square roots of 13. All right. So my radius is 4 square roots of 13. This is going to give us a bit of trouble. Anyone know why? Can't have radicals in the bottom. Uh-oh. All right, sine. Sine is y over r. Okay, I'm actually going to write down here because I'm going to run out of room, but you guys can probably squeeze this in. So if I have 12 over 4 square roots of 13, what's one thing you notice? Radicals in the bottom. Anything else? 12 and 4 can reduce. Let's just go ahead and do that now. This will be a 3 over 1. And then Brad said there's a radical in the bottom, so you're going to have to multiply top and bottom by what to rationalize it? Square root of 13. Now, some of you guys are really good at rationalizing without showing work. That's fine. So I think we have 3 square roots of 13 on top. And then what's on bottom? 13. Good. So there's your sine. That's lovely. Yeah. Okay, cosine. Theta is supposed to be x over r. Ew. Okay, first thing you notice before I rationalize, can you reduce these negative 8 over 4 to be a negative 2? And then can you rationalize? So top and bottom by square root of 13. So up top you've got a negative 2 square roots of 13. What do you have on the bottom? 13. Good. Hard part's almost done. All right, tangent of theta is, oh, that won't be bad. Y over x, 12 over negative 8. But I'd never leave you this answer like that. Why not? You can reduce that. So if you don't want to think, just hit math enter on your calculator. Otherwise, I think we have a negative 3 halves. Okay. Yes. Yes. So we need to come up with the reciprocal functions, and I don't think for cosecant I want to flip this 3 square roots of 13 over 13, because if I flip him, I'm going to have to rationalize all over again. I think I need to back up like one step. Remember, like, 2 minutes ago when you originally had 3 over the square root of 13 right here? What if I just flip that? Tell me what my cosecant is now. Square root of 13 over 3. This is the same answer you would get if you tried to flip and rationalize this one, but flipping and rationalizing this would be a whole lot of work that I don't want to do. Okay, cosine. Think back a few steps. At some point in cosine, I had negative 2 over the square root of 13. So if I flipped that, what would I have? Negative square root of 13 over 2. I think you can't see the side, but it's negative square root of 13 over 2. And then cotangent won't be bad. If you flip a negative 3 over 2, you get a negative 2 over 3. Again, the negative can go anywhere. Top, middle, bottom, doesn't matter. I'm going to do a little aside here. Let's say on cosecant, you tried to do it the long way, and you took 13 over 3 square root of 13. So what I did is I took the sign that you guys fixed, and I flipped it. What would you have to do here to rationalize? You have to multiply top and bottom by the square root of 13. And you get 13 square roots of 13 over, this is a 13 times 3, so 39. And then you'd have to simplify 13 over 39. What is 13 over 39? I think I did something stupid. Oh no, I'm good. 1/3, 1/3. So you'd get square root of 13 over 3, which look what we got. Square root of 13 over 3. Same answer. So if you forget to kind of go back to an easier version of sine to flip, and you do the hard version, it's not the end of the world, you just get a lot of work to do. Okay, well that was fun. Number 5, we've got an x, we've got a y, we need an r. So, Pythagorean theorem, let's see, that'll be 81 plus, oh, yuck. That's really bad. Okay, what is that? 1681. Is that something pretty?
41.
Oh, good. Yes, I think it is. Oh, I'm very happy. After our last experience, I'm very happy to have a radius or an r value that is not a radical because I don't want to have to rationalize for the rest of my life. Okay, sine would be y over r. So we're going to set up negative 40 over 41, and then we're going to be very happy that we're done. Cosine would be x over r, so negative 9 over 41. And tangent would be y over x. Now instead of negative 40 over negative 9, are you guys okay if I just say 40 over 9? Because the two negatives will reduce to a positive. All right, we're almost home free. For the next 3, you just flip them. Now, I'm taking a little bit of a risk, assuming that my first 3 were correct, but that's really the only way that I know how to do cosecant, secant, and cotangent. So, the moral of the story is, when you're setting up sine, cosine, and tangent, don't be sloppy, and make sure you have those 3 right, because if you end up having those 3 wrong, the next 3 will be wrong too. Okay, number 6, we've got an x, we've got a y. I need someone to calculate r for me, and this time it's a radical, so I'm a little depressed, but that's okay. Square root of 5. So my radius, my r, is the square root of 5. Now a little bit of a bummer, we're still going to have to rationalize, but we're not going to have the reduction issues that we had in the last problem, or 2 problems ago. So sine is y over r. So I'm going to start with 2 over the square root of 5, but I wouldn't leave my answer like that. Why not? Can't have a radical in the denominator, so you'd multiply top and bottom by the square root of 5. What do you have up top now? 2 square roots of 5 over 5. Good. The reason I showed the original setup is because when I go to do cosecant, I'm going to be able to flip this one instead. Okay, cosine would be x over r, so 1 over square root of 5. Can't leave my answer like that. If you hit top and bottom by the square root of 5, you'll end up with the square root of 5 over 5. And then tangent is y over x, 2 over 1, which is 2. Okay, cosecant. Go back to your original sine setup, and just flip him rather than the rationalized version. It would be a lot prettier. So square root of 5 over 2. Secant, go back to the original cosine and flip him. If you wrote square root of 5 over 1, you're not wrong. It's just kind of silly. And then tangent, instead of 2 over 1, it's 1 over 2 for cotangent. Okay. We have something called quadrantal angles. I hate saying that word. And the quadrantal angles have to do with the quadrants. It's the endpoints of the quadrants, basically. So, between 0 and 90, the first two axes, that is one quadrantal angle at 90 degrees. Give me an example of an ordered pair that would be somewhere on this positive y-axis. It could be anything. What do you know about the x-coordinate? Does it have to be a 0? And then the y-coordinate would be anything, right? It could be a 1, it could be a 2, 3, 4, a million. So that's why they say if you're at 90 degrees, the ordered pair that would be having a value of theta equals 90 degrees is anything in the form 0, comma, y. Right here, on 0 degrees, sometimes your trig teacher will call this x, comma, 0, but I would argue that the x and the y value, or sorry, the x and the r value are the same value. Does anyone want to tell me why? Let's start with x being x and y being 0. How do you find r? What little formula did we use? Square root of x squared plus y squared. So if I told you your y was nothing, what is the square root of x squared? Just x. So turns out that when you're on 0, your x and your r are the exact same value. So you might want to write a note to yourself. Okay, similarly over here, if you're at 180 degrees, which is called pi radians, that ordered pair would be anything negative r comma 0. Well, again, you could even call it negative x comma 0 because the x and the r are going to be the same value. Okay, 3 pi over 2. They call it 0 negative r, but you could go ahead and call it 0 negative y because the y and the r will be the same value. Okay, just write yourself notes because this is going to be important for when you're doing your homework. Okay. The next concept I'm going to ask you guys about is what's called a reference angle. Okay. Totally new concept. You guys are very comfortable doing right triangle trig at this point. You're very good at sine, cosine, and tangent. And the only way we can do sine, cosine, and tangent is if I give you an acute angle. Well, what if I gave you some crazy angle that was somewhere else in the unit circle? The only way we could create a triangle is if I named what's called his reference angle. And the reference angle is the angle that we're going to call it the terminal side. That means where it ends. The angle the terminal side makes with the nearest horizontal axis. So horizontal axis meaning the x-axis, which is this guy right here. So wherever my ray lands, I need to possibly drop it down or possibly raise it up so that we can calculate the angle between him and the nearest x-axis. Now, one of the textbooks that we use here gives you a cute little diagram for how to calculate reference angles, but in order for you to use such a diagram, you'd have to know it. I'm a more visual person, so I don't memorize how to calculate reference angles. I just look at the picture and figure it out from there, and I'm going to show you what I mean in 1 second. So let's start with 135 degrees. If this is 0, and this is 90, and this is 180, where is 135 degrees? Quadrant 1, 2, 3, or 4? Quadrant 2. It's kind of like up here. So this guy from here to here is 135 degrees. That's me sketching the angle, step 1. Step 2 says find his reference angle. Well, I need to find how far apart angle-wise he is from the nearest x-axis. So his closest x-axis would be this part of the x-axis right here. So his reference angle would be how many degrees separate these two rays. Can someone calculate that for me? If this is 180,
25.
it's 45 degrees. And you probably found that by subtracting 180 minus 35. So his reference angle is 45 degrees. We're just going to calculate what the angle is for now. We'll talk about what to do with it later. Okay, number 8, 200 degrees. Okay, remember this is 0, this is 90, this is 180, this is 270. So where would be 200 degrees? Third quadrant. So if I found the distance between him and his nearest x-axis, this would be his nearest x-axis. I need you guys to calculate for me. Remember this was 200 from here to here. Yep, his reference angle, I heard, was 20 degrees. And we found that by doing the angle 200 minus 180. Okay. Now 5 pi over 3. That gets a little tricky. If you do not like to think of radians, then what you can do is change it to another mode. How do we change radians to degrees? That was last week.
180 times 100.
Very good. So if you don't like radians, which I don't like radians either, you can change it to degrees. So if you multiply by 180 over pi, the pi's will cancel. And I need someone to do 5 times 180 divided by 3 for me. Okay, so this is really 300 degrees. So think about where that lands. This is 180, 270, and this is 360 up here. So I think it lands kind of right here. And you could label it 5 pi over 3 if you'd like, or you could call it 300 degrees. Now remember, his reference angle is how far away he is from the nearest x-axis, the nearest horizontal axis. So you actually have to determine how far it is from, whoops, wish I could draw, there to there. So, 60 degrees, very good. And you could have found that by doing 360 minus the 300, or most of you guys are just kind of visualizing what this looks like. So his reference angle is 60 degrees. What if I asked you to write your answer in radians? What would you have to do next? Yeah, we'd have to convert it. So times it by pi over 180. That's not that hard. Remember, radians, you leave the pi off to the side. I need you to do 60 divided by 180. Math, enter, enter. Yep, pi over 3. Very good. Okay. Moving on. Okay. Find the exact value of each trigonometric function. Use special right triangles. Remember those worksheets of special right triangles I made you do? And you guys are like, oh yeah, I remember this from Geo. There was a reason for that. And that reason is right here today. I want you to find the exact value of sine of 150. So the first thing I need you to do is sketch for yourself where 150 is. Where is 150? This is 90, this is 180. It's kind of right here. So what I need you to do next is I need you to create a triangle. So what I need you to do is from that terminal side, you're going to drop a line straight down. So anywhere on this ray, I'm just going to go to where I ended it, and I'm going to drop a line straight down, and then do you see a little triangle formed? And he, of course, is a right triangle, and I think he's a special right triangle. What angle is it down here at the origin? 30 degrees. That's your reference angle, but even more important, he creates a what sort of a triangle?
30, 60.
Aha, a 30, 60, 90. Okay. So if that's the 90, this is the 60, it's the 30. Remember the pattern for 30, 60, 90s? The little leg was like some number. We called it A. The hypotenuse is twice that size. And then the adjacent, or the 60 degree side, would be A times the square root of 3. So someone give me any number you want for A and make it as easy as possible.
2.
How about 1? Got anything against a 1? Okay. So which part of this triangle is going to be a 1?
A 30.
The guy across from the 30, the little leg, 1. Okay. The next one I think we can fill in pretty easily is the hypotenuse. He's supposed to be double A. So how big is he? 2. And then how about this leg? 1 times the square root of 3, so we'll just call it square root of 3. Now, I know this goes against everything you know about triangles, but I think one of these legs, because of the direction he travels, we could call something other than what I just wrote down. I think one of these legs is actually a negative value. Think about how you traveled to get to this point. Isn't this really a negative? And you're like, wait a minute, sides of triangles can't be negative. Just ignore that for a second and think about the coordinate plane. If you travel to the left, that's an x value. So if you're going left, that's a negative x value. Okay. They just want the sine of 150. I'm running out of room. How do you find sine? Okay, or you could use our new formula, y over r. So who's our y? Which one of these do you think is the y? 1, the one that goes up and down, right? Vertical. Who's the r? That's the x. 2. Very good. Okay, do you guys notice that in the triangle? This would be the y value, this would be the x value, and this would be the r value. It's just like the coordinate plane. The same rules that apply to the coordinate plane are going to apply to this unit circle. Okay. I wish I had more space. I need to write bigger. Okay, 270. Where's 270 at? I think it's one of the quadrantal angles. I think he's down here. So from here to here is 270. Now normally I'd ask you to find a reference angle, but I don't think this guy has a reference angle because his reference angle is 90. He doesn't really make a pretty triangle. However, I think you guys could list me off any old ordered pair that you want to give me that would fall on that axis. And there's 100 million answers, so don't be shy. Give me one ordered pair that would be on that axis. 0, -1, I heard. I like it. So 0, -1 would land right here. You could have said 0, -50, 0, -100. I don't care, as long as it was 0, comma, something negative. What is 0? Your x, your y, or your r? Your x. What is -1? Your y. And then your r, this is kind of confusing because it doesn't really make a triangle, but think about doing Pythagorean theorem. 0 squared plus -1 squared would give you what for your r value? 1. So you've got your x, your y, and your r, and I think you have enough information to tell me your cosine. The new formula for cosine that I want you guys to use, remember, is x over r. So who was your x value? 0. Who is your new r?
1.
And what is 0 divided by 1? Very good. Do me a favor. Go to your calculator. Make sure it's in degree mode. So hit mode, make sure it says degree. And I want you to type cosine of 270. And tell me what your calculator gives you. It gives you the answer of 0. Okay, what about the first problem we did, sine of 150? Type the sine of 150. Tell me what your calculator gives you. 1/2 or 0.5. That doesn't mean I want you guys using your calculator for everything though, because I've purposely given you pretty nice ones. They don't all come out pretty and nice. So you can use your calculator to check, but not to do the problem. Okay, cotangent of 135. Oi. Draw yourself 135. let's see, 90, he's off of 180 a few degrees. He's up here, kind of. So right here is 135. I need you to create your triangle by dropping a leg down and over. And I need to know what kind of a triangle I have. It's a 45, 45, 90. Do you guys see that? Because if this is 180 and this is 135, it's 45, 45, 90. Okay. So, think about how 45, 45, 90s work. This was the easy one, right? The legs are the same. We called them A usually. And then the hypotenuse was A squared to 2. So I don't care what you call them, but someone give me how long you want the legs to be. 1 sounds good. So the y coordinate, the vertical leg, we're going to call a 1. And normally we would call the x a 1 as well, but tell me what you know about the coordinate plane traveling to the left. He's really going to be a -1 for the x. How big would your hypotenuse be if he's your leg times the square root of 2? R is always positive. Square root of 2. 1 times the square root of 2 is square root of 2. Okay, so we just found your x to be -1, your y to be 1, and your r to be the square root of 2. I want you to find cotangent. What is the formula for cotangent? I'll take either formula at this point. He's the upside down version of tangent, if that helps you.
Y over x.
That's tangent, so give me cotangent. X over y. So I need to fill out x over y, which would be, oh, that's easy. -1 over 1. What is -1 over 1? -1. Good. All right, I'm desperately running out of room. So let me insert a blank slide. Tangent a -30. Okay, let's draw this. Remember, it goes counterclockwise normally when you're going positive. So when I'm going -30 degrees, that means I'm going to travel clockwise 30 degrees. Woo, that's not a good angle, but pretend. So I went -30 degrees. This is my terminal spot. Just stop it somewhere. And then this time, drop a leg up and create yourself a little right triangle. What kind of a right triangle did I just create? A 30, 60, 90. So remember, 30, 60, 90s. Oh, jeepers, that's terrible. The pattern is A, 2A, and then A squared to 3. What would you like to call your A? 1. Okay. Now, I'm okay with you guys calling it a 1, but since it's a vertical leg and it goes down, what should I really call it? A -1. Good. Now everybody else should be positive. So your hypotenuse is double the length of the little leg. So if I double a 1, I get a 2. And my medium leg is your little leg size times the square root of 3. So instead of 1 square root of 3, I'm just going to write square root of 3. Okay, I think we're ready to set up tangent. By the way, are all my signs good? The x value would be positive, but the y value would be negative. So this is your x, this is your y, this is your r. Okay, what's the formula for tangent again? Y over x. So if I start setting that up, I'd go -1 over square root of 3. But I can never leave my answer like that. Why not? I have to rationalize. So top and bottom by the square root of 3. And you end up with, I really need more room here, negative square root of 3 over 3. If you type in the tangent of -30 into your calculator, you're going to get a decimal, and that decimal is equivalent to negative square root of 3 over 3. As you do more and more trig, like if you go to a trig class, you'll start to recognize certain decimals because there's certain ones that show up again and again and again because there's a pattern to the unit circle. All right, I know this is clear as mud right now, guys, but we just kind of have to try. Okay, I'm going to back up a couple slides. Woo! That is not what I wanted to do. This is what I was referring to earlier. So those of you who've had ACT prep, you saw this mnemonic device before, ASTC, and that stood for All Students Take Calculus. And it doesn't have to be true, it's just a mnemonic device. What that meant was if you took the first letter from each of those words and put them in the quadrants, all students take calculus, that tells you which trig functions are positive in that quadrant. So in quadrant 1, that was A, that literally meant all of your trig functions are positive. Sine, cosine, tangent, and their buddies. But in quadrant 2, do you see the S? That stood for sine. Do you notice that only sine and his buddy is positive, but everybody else is negative? In quadrant 3, T stood for tangent. Did you notice that tangent and his buddy were positive, but everybody else is negative? And then what do you think C stands for? Cosine. So notice that cosine is positive, but his buddies are negative. The other guys are negative. The reason I bring that up now is because once I have my answer written down, I try to think, was my answer supposed to be positive or negative? So for instance, when I did tangent of negative 30, what quadrant was negative 30 in? What number is this quadrant? This is number 4. Was tangent supposed to be positive or negative in quadrant 4? It's supposed to be negative. Did I get a negative number? Yeah, it's over here, but yes. And that would have to do with the fact that you guys remembered since he went down 1 unit, we're going to call him a negative 1. Okay, let's keep going. Tangent of pi over 4. Maybe you don't like pi over 4 because it's radians. How could you rectify the situation? Could you convert it? By multiplying by 180 over pi? So on your calculator, what is, the pi's cancel, so what's 180 over 4? This is really the tangent of 45. Okay. So draw 45 degrees, which would be like right here. And then stop your ray and create a triangle. Oy, goodness. Is your answer going to be positive or negative? It's going to be positive because you're in quadrant 1 and everybody's positive in quadrant 1. Okay, what is the angle right here in this triangle? 45 degrees. So we have a 45, 45, 90. What would you like to call the legs? I'm going to call them 1. That sounds good. What would you call the hypotenuse if the legs are 1? Square root's of 2. So now we're ready to set up tangent. Tangent of 45, remember, would be y over x, or if you wanted to say opposite over adjacent, that's fine. Either way, it's 1 over 1, so the answer is 1. Okay, 4 pi over 3, I don't know what that is. So we're going to multiply by 180 over pi on our calculator. Pi's cancel. What's 4 times 180 divided by 3? What was it? 240. Okay, we need to draw ourselves a little picture. This is 180, this is 270, so I think 240 is backed off of 270 a little bit. So like right here. Oh, jeepers. Wish I could draw a straight line today. Oh my goodness. So terminate your leg and, oh my gosh, that's even worse. Create a triangle. The good news is it doesn't matter what your picture looks like because this is going to be okay. If this is 180 degrees and this is 240 degrees, the reference angle is what I'm looking for. Can someone tell me what angle that is? I heard 60. What kind of a special right triangle do you have now? A 30, 60, 90. Okay. The little leg is how we start the pattern. What would you like to call the little leg? 1. Why not? And because we traveled to the left, can we go ahead and call it a negative 1? I know legs aren't normally negative, but I'm just saving us some issues later. The hypotenuse should be twice the size of the little leg, but he's going to be a positive number because he's always positive. So what it would be double 1? 2. And then the medium leg would be this times the square root of 3. And since he's going down, should it be a positive square root of 3 or negative square root of 3? Negative square root of 3. All right, let's set up cosine now. Cosine of 240 should be x over r. Well, your x is a negative 1, and your r is a 2. There we go. Should cosine have been negative in quadrant 3? All students take calculus. Should cosine be negative here? Yes, because tangent's the only one who's positive. All right, let's do one more. Cotangent of negative pi. Okay, this is 0. If I go negative pi, that means you're going to travel this way instead, but you still end up right here. Can someone give me any old point that would land right here? How about negative 5, 0? Okay, because it's left. So if we want to call our x 5, negative 5, and our y 0, you can do a quick calculation to figure out r. So a little Pythagorean theorem. Surprise, surprise. What do you find for r? Do you get 5? I guess that makes sense since I traveled 5. So if your x is negative 5, your y is 0, your r is 5, and I want cotangent. The formula for cotangent is the upside down version of tangent. Well, tangent is y over x. Cotangent is x over y. So your x is negative 5, your y is 0. Careful, guys. What is it called when you divide something by 0? Undefined. I don't want you to put 0 with a line through it. That's not the same thing. Okay, so your answer here, cotangent of negative pi, is undefined value, meaning it doesn't have a value. All right, I didn't get to the last one, but I want you guys to start your homework on 3-3 tonight.